Okay, we're going to go over some strategies for solving equations. The first bit is going to be just reasoning through figuring out what the variable is by inspection. That means that we can use our mental math to figure it out. And then the second way, we're actually going to go through an algebraic process to show our work of how to solve. So a lot of these questions you probably will be able to figure out just by looking at them. So the first thing that we need to understand is, what is the expression talking about? So the first one is j plus 4 equals 12. So j is a variable and it means some number. So some number plus 4 equals 12. So we need to figure out what that some number is. So you could try a bunch of things, but hopefully your mental math has told you that that some number is 8, and then we just make sure that it is correct. So then this side, a plus 4 is 12, and 12 equals 12. So that must mean that j has a value of 8. Okay, this means we have some number minus 9 equals 17. So that probably means that our initial value most likely was larger than 9. So we just need to figure out what that relationship is. So you can count forward. So we started with some number, and when we took 9 away, we got 17. So if you want to start at 17 and work your way backwards, up 9, then you're going to end up with a value that d is 26. Okay, so if you want to test yourself, pause the video, see if you can figure out what k is, and see what you can figure out, see if you can figure out what t is, and then you can play the video and see if you get the same as I do. So for this one, it means that we have some number plus 5 is going to equal 14. This one means some number take away 3 equals 11. So let's figure out what these are. Some number plus 5, well, that number must be 9. Some number take away 3 ends up at 11, so we must have started at 14. This is solving by inspection. Okay, now we're going to look at this word problem. Stephanie and her sister cycle 4 kilometers to a shopping mall, then travel farther to their mother's office. If they cycle 11 kilometers in total, how far is it from the shopping mall to the office? Okay, so anytime that you're having a word problem, it's always good to kind of visualize what it's talking about. So Stephanie, they start here and they go to the mall, and we know that's 4 kilometers. That's the mall. And then they keep going to see their mom, and they know that from the start to the end, we know that that's going to be 11 kilometers. So we want to figure out how far is it from the mall to their mom. So if we want to kind of look at it in cups and counters, we know that the total kilometers would be 11. So we know that some distance plus the 4 kilometers they already went must equal 11. So we need to figure out how many are in this cup. This model is showing how this relationship works with balance scales, remembering that if you want to solve for this one right here, you're going to have to, whatever you do to one side, do to the other. So I'm actually going to walk through this example using the balance scale. So how this works is if I take one of these little squares off of this side, then this side would be heavier, so it would fall down. In order to maintain balance, I would also have to remove one off of this side. So then I'd take another one off, another one off, another one off, another one off, and the fourth one off. So now I'm going to be left with my question mark, or my D value. And it's going to tell me that it's equal to 1, 2, 3, 4, 5, 6, 7. Now, if we do this algebraically, what did we do? So off of this side, we removed 4. And then off of this side, we also removed 4. Because whatever you do to one side, you have to do the same to the other to keep that balance. So what ended up happening is after I took away all those 4, I was left with just the D on this side, and I was left with the 7 on that side. So this is very much what our algebraic process is going to look like. So flip over. There's a couple basic rules for solving any algebraic equation. So we use the opposite operations to solve. So if there is addition, then we're going to have to use subtraction to solve. And if there is subtraction, we're going to have to use addition. And then whatever you do to one side, you must do the same to the other. And that's what maintains balance. Now, anytime that you're trying to get a variable by itself, it's called isolating the variable. So if at any time you ever hear me say you need to isolate, it means you need to get that variable by itself and have a value of 1. That's very important. One whole variable, we want to figure out its value. So we have C plus 22 is equal to 56. So right now I have C and I'm adding 22. The opposite operation would be to subtract 22. And then that other important thing, whenever I do to one side, I have to do the exact same thing to the other. So I have to minus 22. Now, some people like to put a line underneath because you could just do any borrowing or regrouping or anything like that, if that helps. There's also a bunch of people who like to put a line down here so that they remember that you're working on both sides of your equation. So if we think about our integers, this is a zero pair or opposite integers. So if we have 22 positives and 22 negatives, those are all going to cancel out and create 0. You're going to be left with C on this side. And then I have to take 56 and I have to minus 22. So then C must be equal to 34. Now we can always check, and if you are checking, it's also called to verify. We have C plus 22 and it needs to equal 56. So that being said, if 34 plus 22, if that equals 56, then we're good. And it does. Once you end up with 56 on both the left side and the right side, it's verified. We know for sure that that is the solution. Okay, let's try the next one. So some number plus 7 equals 26. So right now I'm adding 7. So the opposite operation is to subtract 7. Whatever I do to one side, I have to do to the other. Okay, and then apply that. Those zero out. I'm left with n. And then 26 minus 7 leaves me with 19. And we're going to verify it. And I'm going to call one the left side and the right side. Ooh, dropped my pencil. The left side of the equation says n plus 7. The right side says 26. My n value, I think, is 19. 19 plus 7 is 26. So we are good. And last example that we're going to do right now, we have d minus 3 equals negative 5. So right now I'm taking my variable and I'm taking 3 away. So the opposite operation is going to be to add 3. Whatever I do to one side, do to the other, apply my operation. 0 pair, left with a d, negative 5 plus 3. So I didn't quite get out of the negatives. I still have 2 negatives. Now we're going to check. So my d minus 3 is on my left side. Negative 5 is on my right side. I think my d value is negative 2. If I have negative 2 and I take 3 more away, going more into the negative, so I end up with negative 5 equals negative 5. So anytime that left side equals right side, you've verified your solution.